I'm out here in Lofoten, Norway, shooting the Northern Lights, which is one of the really cool parts about my job. Lofoten in Northern Norway is among the best places to catch a glimpse of the Northern Lights, and I've been lucky to capture several ones while I've been here. The Northern Lights are an incredible natural phenomenon where greenish or reddish light seemingly dances through the sky. If you're lucky to travel far enough north or far enough south, then you might be able to catch the auroras during the dark, long nights of winter. But even being in the right place during the right season doesn't guarantee a viewing. These tiny dancers can be difficult to find sometimes, which is why I will spend some time showing you the best ways to track down the auroras. We'll also learn what exactly these mystical lights are and where they come from, based on science and based on the people and cultures who have lived below their beauty for centuries. We have all seen images of the auroras, and you might even have heard that the auroras come from the sun. But understanding how they form helps us know how to have the best chances of seeing them. In the simplest of terms, an aurora appears when electrical particles coming from the sun collide with the Earth's atmosphere. The energy gathered from the sun and the long voyage heats up particles in our atmosphere, and that produces light. But how exactly do those particles appear, and why do auroras only happen at the poles? Well, to understand that, I'm afraid we are going to have to dive a little deeper into the science.
On the sun surface, you can have different eruptions. You can have eruptions of X-rays, energetic particles, but also as huge bubbles of charged particles, and these bubbles have their own magnetic field structure. These bubbles propagate from the sun to the earth in 1 or 2 days.
This bubble is called a coronal mass ejection, or a solar storm. And from this point, Kirsty suggested that we think of the process like a hockey match.
So you can imagine that the sun is like a hockey player shooting the hockey puck towards Earth. First of all, you need to kind of follow whether the puck has a correct direction, so it's coming towards Earth or is it going by. Well, if it is coming towards Earth, then you need to follow how the goalkeeper is performing. And in this case, the goalkeeper is our own magnetic field.
The Earth's magnetic field, the magnetosphere, acts like a shield and deflects some of those storms. Although auroras can only seem like a good thing, they can have harmful effects, especially in our modern world. Solar storms can damage communication and electrical equipment, so a lot of people actually don't want the storm to reach us. But from our point of view, we want the storm to defeat the goalkeeper. And those storms that make it through are transported down the magnetic field to the poles, where the magnetosphere is weaker. The charged particles that reach the poles end up bashing into gases in the Earth's atmosphere. The energy from those collisions is released as light, and we see that light as an aurora. Chasing the Northern Lights takes me to many countries. So I wanted to share an offer we've got for anyone wanting internet access overseas with the sponsor of this video, SIM Local. For those unaware, an eSIM allows you to keep using your existing SIM card, so all your usual phone calls and messages still work like normal. But then you can have a second electronic SIM that handles your international data at a much lower cost. With SIM Local, you can set up everything before you fly, so as soon as you land in a foreign country, you'll have internet access. I found this really useful for checking public transport information or hiring a taxi to my hotel, no searching for public Wi-Fi or looking for overpriced SIM cards in the airport. SIM Local operates in hundreds of individual countries as well as regional packages that allow country hopping around Europe. Their plans cover a wide range of allowances for different budgets and with a top rate at Trustpilot score. Since you prepay, you can use your phone with no danger of spending more than you planned. So use the link below or QR code before your next trip and get a 10% discount whenever you use discount code BRIGHTTRIP. Alright, now let's go back to the video. Scientists believe that the auroras in the North and South poles are almost like mirror images of each other.
So if you look at the auroras from very far above, from a satellite, actually you can see the overall picture of the auroras from the southern hemisphere and from the northern hemisphere are in general similar. So the shape is like an oval shape, like a halo on the head of the angel.
This is called the aurora belt, or aurora zone. And while the auroras are mystical and magical to us here on Earth, they're actually not uncommon in our solar system.
The critical thing is that the planet needs to have this magnetic field, so that kind of organizes the particles, and you can see then the auroras. So examples of other planets which do have auroras are Jupiter, Saturn, Neptune, and Uranus at least. And then there are some speculations that maybe in Mars you could also see a bit similar airflow as auroras. Auroras in the Earth are different from the auroras on the other planets in colors. So in Earth you can see these auroras with your naked eye, so they are visual wavelengths. While on the other planets the auroras are in ultraviolet wavelengths or infrared wavelengths, or the colors can be different. So in Earth the green color is dominating, but if I remember correctly, it was in Saturn where the red colors are dominating.
So auroras aren't unique to our planet, but the journey of an aurora is quite a long one, from the sun all the way to the Earth. And from the direction of the solar storm to its magnetic field, so many things have to be in alignment for an aurora to happen. It's an incredible journey, and for me, it makes the experience of watching an aurora that much more special. The first thing that you need to think about if you want to see an aurora is location. There are definitely some places in the world where you have a much higher chance of catching the light show. Let's take another look at the map of the aurora belt. Even though auroras can sometimes happen closer to the equator, that's a rare occurrence. So your safest bet is to be somewhere in the belt. Here in northern Scandinavia, I recommend Tromsø, Alta, Lofoten, and Abisko. Other great locations around the world are Iceland, northern Russia, northwest Canada, or Alaska. On the other side of the world, you will find your best chances of seeing an aurora in Tasmania and the south of New Zealand. But really, the southern lights mostly happen in Antarctica. So now you know where to go. The next thing is to think about when to visit. Auroras actually happen throughout the whole year, but you need a dark sky in order to see them. The nights are much longer in fall and winter, so that's when it makes sense to go and see the lights. And here in the Lofoten, we are so far north that the sun doesn't set for a couple of months in the summer, so your chances of seeing the show are basically non-existent. For the Northern Hemisphere, the best months are from September to March, and for the Southern Hemisphere, the best months are from March to September. The one thing I can't answer is how long your trip should be. Unfortunately, the aurora activity depends on the weather conditions and sun activity. These factors are really hard to predict in advance, so the longer you're there, the better your chances are of catching a night with the right conditions. Just be aware that wherever you go, you're not guaranteed to see the auroras. But if you're somewhere like Lofoten in January for a couple of weeks, you'll be giving yourself the best chance of ticking it off your bucket list. You don't have to, but going through a guiding company can make the whole experience easier as well. They know the conditions really well, will provide transportation to the best locations, and can help make the experience more enjoyable. Once you arrive at your chosen destination, I recommend that you check the forecast daily. There are two forecasts that you need to take a look at: the weather forecast and the aurora forecast. Let's start with the weather forecast because it's a bit more familiar. The key metric that we need to check is cloud coverage. There are three types of cloud cover: low clouds, medium clouds, and high clouds. Medium clouds are the ones you need to watch for.
And the medium clouds are the worst clouds for observing northern lights because they are very thick and they are not affected by wind. They are between 2,000 and 7,000 meters, and the light from northern lights will not go past them.
So if medium cloud cover is going to be 85% or more all night, you're probably not going to see the auroras behind the cloud. Next, you should check the low cloud cover. They could be considered the largest clouds, but they might not affect your view too much.
We've got low clouds, and low clouds are affected by wind very easily, so they can spread and move very, very fast, especially when you're observing northern lights on a coast.
Especially here in the Lofoten, where strong winds are very frequent. Up to 60 to 70% of low cloud coverage shouldn't scare you away from chasing the northern lights, especially if it's going to be windy. Finally, high clouds are of least concern. They tend to be thin and somewhat transparent, so even if you have 70% coverage of high clouds, you still have a chance to catch the aurora. I recommend using an app called Windy to check the cloud coverage. It's simple to use and allows you to distinguish between high, medium, and low clouds. You could also use local apps to check general weather conditions like yr.no here in Norway. Once you've checked the weather, the next step is to check the aurora forecast. The first thing to understand is that aurora forecasting is nowhere as accurate as weather forecasting. Forecasting auroras is a challenge because you need a lot of information that we don't always have. So it's best to check the aurora forecast for the same evening. There is little point in checking the aurora forecast for tomorrow. Now I know, an aurora forecast might look a little overwhelming, but I want to talk through the key things that you need to check. The first one that I want to show you is solar wind density. How thick will the aurora be? And how visible would it be? That's where solar wind density comes in. The more particles there are, the higher the chance that they will collide in the Earth's atmosphere and kick off an aurora show.
Everything above 8 is really nice, and for me the best one is around 15-20, because then the aurora is thick and really green.
The most important factor is the interplanetary magnetic field. It sounds kind of complicated, but I promise it's not. This is basically a measure of how well the solar wind and the Earth's magnetosphere interact.
This is like a door for aurora to enter our magnetosphere. We are in the northern hemisphere, so we need this to be in negative. Now it's -4, so for northern lights in the northern hemisphere is really good. Everything below 0 is perfect for observing northern lights. Of course, in positive you will be also able to observe northern lights, but it needs to be really high density to be visible on the sky.
Next, there is hemispheric power. This is the measure of auroral activity. How much force would the aurora generate?
It basically means how much power the aurora will generate. For me, the best ones is around 30 gigawatts. Now we have 18 gigawatts. So if the aurora will appear in the sky, it will be visible, but not so strong.
And finally, there is solar wind speed.
It's how fast the aurora will move through the sky. When it's over 400 kilometers per second is the best for observing the northern lights live, because the aurora will start to move, and we call it dancing. When it's faster, it's better for observing northern lights, for experiencing northern lights, and for the pictures.
Ideally, you want several of these parameters to be favorable for a good aurora forecast. You can find the aurora forecast on the internet or on an app called Space Weather Live. So now we know how to prepare for a night chasing the northern lights. The last thing is to actually get out there and watch the sky.